What is up, YouTube? Mr. King coming live from the 209. Here are the questions for the day. Please pause the video and answer them now. Number 3 is some review from yesterday. If you don't know how to do this problem, look at the video for Tuesday. For Wednesday, we're going to be learning about anions versus cations. Okay? So pull up these notes. So I have a little analogy to help you remember. Cats have paws. So cations are positive. Cations are positive. Cations are positive. And a student helped me come up with this. Thank you, Diego. Anions, anion sounds like anti. And anti means against. So anions are negative. Sounds like anti because it's against. Remember, like antibiotic kills bacteria. The Antichrist is the devil. It's like anion, anti, very similar. So just remember, anion is like against, like it's like anti, so it's negative. And I drew this little picture for you to help you remember. Anions are negative. So if you gain these electrons, if you're gaining electrons, you're going to be negative in an anion because electrons are negative. Okay. Here is how you do a sample problem. I accidentally showed you the answer, so we're going to skip that one. We'll do selenium. Step 1, you have to figure out how many valence electrons does selenium have. To figure out how many valence electrons Se has, use the periodic table. So find selenium. Selenium is right here. Since it's in this column, remember it goes 8, 7, then 6 valence electrons in this column. So selenium has 6 valence electrons. So you're going to add 6 valence electrons to the first selenium, the one on top. Okay. That should be 2, 3, 4, 5, 6. Okay. Next, determine if it's closer to 0 or 8. So 6, closer to 0. 6 is closer to 0. So what that means is that if it's closer to 6 is closer to 8. 6 is closer to 8. So if it's closer to 8, add electrons to get to 8 on the next one. So 6 closer to 8, so you're going to add all the way up to 8. Selenium is 6, but it needs to be 8. So selenium is going to gain 2 electrons. So it can be the full, complete orbital that it wants to be. Doing my best to draw them on the computer. Okay, so selenium has 8 now. Okay, and it gained 2 electrons. And though, remember, electrons are negative, so it's now 2 minus because it gained 2 negative things. And remember, anion is like anti, so it's against, so it's negative. Anion is negative, so selenium is an anion. So that's what you do if the valence electrons are closer to 8. However, let's try for aluminum. First, we have to figure out aluminum's valence electrons. So find aluminum on the periodic table. Aluminum is right here. And it's in, remember, column 1 is 1, and 2, you skip these, and then you go to 3. So aluminum is in column 3, so it has 3 valence electrons. Since aluminum has 3, we're going to add 3 dots. 1, 2, 3. And then determine, is 3 closer to 0 or is it closer to 8? Unlike selenium, which had 6, 3 is closer to 8. So we're going to lose these 3 electrons. So we don't have to do anything for this Al. Now it has 0. It lost these 3 electrons. It went back down to the orbital before. So it has now you have to figure out the charge. It lost 3 things that are negative. And for everything that you lose that's negative, you get a plus. It's like losing negative numbers or toxic friends. If you lose toxic friends, you're going to be more positive because you don't have that negative energy. So aluminum lost 3 negative things, so it's going to be plus 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 or 3 plus. And remember, cations are positive. Positive. So aluminum has a plus 3, so it's a cation. That's how you do these problems. Figure out the valence electrons closer to 0, remove them, and for every one you remove, it's a plus. If it's closer to 8, you add them, and for every electron you add, it's a minus because electrons are negative. That's the last thing. Before you go, please take the survey. And then you're all good to go. Thank you so much, everyone.